In this tutorial, I'm going to talk about operational amplifiers, or op-amps, because they are the easiest type of amplifier for beginners to work with. I'll also show you a microphone amplifier circuit that you can build to listen to your heartbeat or spy on people that you don't like. So, what is an amplifier? Generally speaking, an amplifier takes a small voltage on the input and spits out a bigger voltage on the output. The gain of the amplifier is the amount that you're multiplying the voltage by. For example, here's an amplifier that takes 1 volt on the input and gives 5 volts on the output, so we say this amplifier has a gain of 5. Now the diagram I'm using here with the triangle is just a simplified symbol, so let's take a look at a more formal circuit diagram. A bare operational amplifier will have 5 important pins. Over here we have the output pin. Your output voltage would come out from here. The plus and minus pins are the inverting and non-inverting inputs of the op-amp. Don't worry too much about what that means for now, just realize that these are not the power supply pins, they are your signal inputs. Now these pins are the positive and negative voltage supplies for the op-amp. These voltage supplies need to be at least a volt or two more than the output voltage you are expecting. For example, let's say your output wave is expected to be plus 10 volts to minus 10 volts. You'd probably want to power your op-amp with plus 12 volts and minus 12 volts. Now the reason you do this is because unfortunately amplifiers can't create voltages out of nowhere. You would need a totally different circuit for that. If you don't give your op-amp enough voltage, you will get clipping on the output voltage, and that would mess a lot of things up. While you're sorting out your supply voltages, make sure you put some capacitors on the power supply lines to smooth out the power. Also, if you hook up 2 batteries in series like this and call the center terminal ground, you'll get a really good positive and negative voltage supply for your op-amp. Now this thing alone isn't going to be able to amplify anything. You're going to have to add a couple of other components to configure your op-amp to have the right gain. I'm going to show you one of the simplest amplifier circuits you can build, the classic non-inverting amplifier. With the non-inverting amplifier, you set the gain with resistors. The gain is given by 1 plus R2 over R1. So if R1 is 2 kilo ohms and R2 is 10 kilo ohms, you get a gain of 1 plus 5, which would be 6. You usually want these resistors to be somewhere in the kilo ohm range, so an easy thing beginners can do is just let R1 be 1 kilo ohm and use this equation to calculate the value of R2 to get the gain that you want. Alright, I'm getting sick of theory now, so let's actually build something. I want to build one of those spy listening circuits that picks up faint sounds on a microphone, amplifies them, and lets you hear them on some iPod earbuds. By doing a few measurements with my oscilloscope, I found out that a microphone puts out a tiny voltage of about 20 millivolts peak to peak. By doing some more measurements, I found out that I need to give my earbuds about 2 volts peak to peak to be able to hear things loudly. So I need to take an input waveform that is 20 millivolts and increase it to 2 volts, meaning I want to design an amplifier with a gain of 100. Okay, here's my final design. The microphone is just one I ripped out of a dollar store computer microphone and I soldered some wires to it. And this part of the circuit is used to power the microphone. This part of the circuit is called a high-pass filter, and it removes any DC voltage coming out of the microphone to make sure that we're only amplifying a pure AC audio signal. The op-amp itself is one of my favorite op-amp chips of all time, the LM324, and you can buy them at Radio Shack. The LM324 is actually 4 op-amps in one, and you only have to use as many as you want. To power the amplifier, I'm going to use the same 9-volt battery circuit that I showed you earlier. If you look at the resistor values I've chosen here, you can see that they'll give the amplifier a gain of 101, close enough to 100. Finally, I added a variable resistor to the output to give me some control over the volume. Hey, wake up, we're almost done. Alright, here's what it looks like built on a breadboard, and guess what? It works. If you turn up your subwoofer, you'll be able to hear my heartbeat. You can also use the circuit to amplify other sounds. So far all I've talked about is changing voltages, but it's important to realize that just because you can have an amplifier that can put out 10 volts or whatever and has a gain of 100, it doesn't mean that you can actually supply much current. For example, the little LM324 I used here can only handle a few milliamps. That's enough to power a pair of earbuds, but it would be useless to power a proper home theater system. For that, you'll need an amplifier chip that can actually deliver a couple of amps of current, such as the LM1875 made by National Semiconductor. Check out the sample circuit on the LM1875 datasheet. It looks very similar to the circuit I just showed you, doesn't it? The truth is, most op-amp chips are really quite simple to work with, and all you really need to do is pick the right op-amp, give it the right power supply voltages, and set the gain using a couple of resistors. All the extra components are for filtering, and that's going to be the subject of another tutorial. Alright, I'm done. Here's some more cat noises.